My name is Prithvisha Nath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering. This is week 6 for this course. We will solve some problems on friction this week. So let's start. So this is the first question. A mass of 10 kg is being lifted using two frictionless massless pulley arrangements, namely A and B as shown, using an inextensible rope. What is the ratio of mechanical advantage in arrangement A to that in arrangement B? So can you try solving this question? So for case A, this is 10 kg, so the force will be 10 g. Now, and for the second case, the tension here will be Pb, so here it will be 2 Pb. So from the first case, it is Pa equals to 10 g and Pb equals to 10 g by 2, that is 5 g. Now, what is the mechanical advantage for the first case? Mechanical advantage ten g by Pa, which is 10 g by 10 g, that is equals to 1. And for the second case, mechanical advantage is 10 g by 5 g, that is equals to 2. Now in the question, we are asked to find the ratio of the mechanical advantage. In arrangement A to that of arrangement B. So, ratio will be 1 by 2, that is 0.5. So this is the first problem that we are solving. We need to find the ratio of mechanical advantage in both ratio of mechanical advantage in arrangement A to that of in arrangement B. So these are the free body diagrams for case A and case B. Now we found out the mechanical advantage for the first and the second case. Then we took the ratio, which is 0.5. Is there any doubt regarding this problem? can tell me if you have any doubts. Okay, so the next problem. The condition of self-locking is influenced by which of the following parameters? Now this is a very simple question. Can you answer? Answer me which are the following parameters? So the condition of self-locking is influenced by material of the wedge, material of the object to be self-locked, and angle of the wedge. Now the next problem. I suggest that you try solving this problem. A massless rigid link AB of length 150 mm is hinged to a uniform wheel of mass 25 kg at point B and to the floor at point A with smooth pins as shown along with the coefficient of friction between wheel and floor. A couple M is applied to the wheel such that its motion is impending at the contact point with the floor. Now we need to solve the given question. In the current configuration, link AB is a two-force member under uniaxial compression. The second problem is what is the magnitude of the normal force exerted on the wheel and what is the magnitude of force experienced by the link at point B. And finally, we need to determine the magnitude of applied couple M such that the state of impending motion is attained. So, first you should try drawing the free body diagram for this problem. Now can you tell me what angle is this? Can someone tell me what is this angle from this diagram? have the diameter of the radius of the wheel as well as the link length 150 millimeter. So from there can we determine the theta? Can you tell me what is the value? So sine theta will be 75 by 150, right? So theta will be sine inverse of 75 by 150. So theta is 30 degree. Is there any doubt regarding this? Okay. So now suppose this is the coordinate axis, reference coordinate axis. Now I'll draw the free body diagram first. So there is a normal reaction here. Can you tell me which direction should be the friction force acting? Which is the direction? Can you tell me? Let this force be P. And can you tell me the direction of frictional force? This is theta. Frictional force tries to resist the motion. So it should act in this direction, right? Okay. So this is the free body diagram. Now I'll write force balance in the y direction. So N, this is 25 kg, right? Yeah. So mass of the wheel is 25 kg. So force will be 25 into G. So minus 25 into 9.81 plus P sine 30 degree. So N will be 25 into 9.81 minus P sine 30 degree. Similarly, for in the x direction, we can write F1 minus P cos theta equals to 0. So P cos theta equals to F1. So here it is mentioned that the motion is impending, right? So I can write F1 as mu s times the normal force, right? So I can write this as P cos theta equals to mu s into normal force. So P equals mu s into normal force by cos theta, cos 30 degree. Now I can find the normal force by substituting the value for P in this equation. Suppose this is 1. Now I'll just substitute n equals to 25 into 9.81 minus mu s into n cos 30 into sin 30. So n into 1 plus mu s tan 30 degree equals to 25 into 9.81. So from here n equals to so can you tell me what this value is? It's 209.04 Newton. Up till here, is there any doubt? We found out the normal reaction. We found out the normal force. So is there any doubt regarding this? Up till here, is there any doubt? Okay. So we found the normal force. Now, from the normal force, we can get the force P. So P equals to mu s into n divided by cos 30. So mu s is 0.3, normal force is 209.04 divided by cos 30, which is equal to 72.41 Newton. Now, so we already solved the first question is the current current configuration the link AB is a two-force member under axial compression. So you can see, right, it's in compression, this member AB. We solved it already. So this is true. What is the magnitude of normal force? We just now found it out. So it's 209.04. Now the next part of the problem, what is the magnitude of force experienced by link at point B, which is nothing but this force P, right? We need to find the force at this point B, which is nothing but P, right? So we also found this out. So the magnitude of the force experienced by the link at point B is point B, yeah. Point B is how much? 72.41 Newton. Up till this point, is there any doubts? You can ask me if there is any doubt. Okay. So the next part of the problem, determine the magnitude of the applied couple M in Newton meter such that the state of impending motion is attained. Now you can see there is a moment applied. There's a couple applied. Couple M applied, see. So there is a couple M applied at the center. So we can let this point be O. So we can calculate the moment about point O and then find out the value for M, right? So I'll draw the free body diagram once again. This is F1, this is N. This is O, and this is P, and this is angle theta. Now, if anticlockwise moment is considered as positive, and we know from the given diagram that this radius is 75 millimeter, right? So P sine theta sine 30 into 75 into 10 to the power minus 3. We are asked to find it in Newton meter. So, and F1 is causing an anticlockwise moment, right? So this is also positive. F1 into 75 into 10 to the power minus 3, and the moment is in clockwise direction. So this should be minus m equal to 0. So m equals to P sine 30 plus F1 into 10 to the power minus 3. Now P is calculated as 72.41 into sine 30, and F1 is mu s. Mu s is 0.3 multiplied by n, right? So which is 209.04 into 10 to the power minus 3. So this becomes there is a 75 here also, so into 75. So this comes out to be 7.42 Newton meter. Am I audible? Can someone confirm if I am audible? Okay. So is there any doubt regarding this? Okay. So the next problem. Just try solving this problem. You just need to draw the free body diagram and then you need to find the magnitude of normal force at A and the coefficient of static friction between the ladder and the floor. So the problem is one end of the ladder weighing 700 Newton rests on a horizontal floor and the other leans against a smooth vertical wall. As shown, the ladder is at the verge of slipping when a man weighing 500 Newton climbs and stands on the ladder at a distance of 2 meters from the bottom of the ladder as shown. So first I will suggest that you try drawing the free body diagram for this. And can you tell me the normal force I take? So can someone tell me what is the magnitude of normal force at point A? Okay, so I will first draw the free body diagram. So this angle is 60 degree. Here there is a normal force at B. This is NB and this is point A. So this is NA. And which direction should the frictional force act? Can someone tell me which direction? This direction, right? This is the direction of frictional force, right? So now, and the weight is 700 and weight of man is 500 Newton. This is 2 meter and this distance is 3 meter and this entire distance is 6 meter. So if I write force equilibrium in x direction, it can be seen that NB equals to Fa, right? Similarly, in y direction it is Na minus 500 minus 700 equal to 0. So Na equals 1200 Newton. Is this clear to everyone? Is this, yeah. So now we need to find NB, that is the reaction normal force at B. So calculating movement about A. So what is this distance? Can you tell me? What is this distance? It is 6 sine theta, right? So NB into 6 sine theta, that is 60, (500) is causing a clockwise movement, so it should be negative 500 into 2 cos 60, right? And 700 is also causing a clockwise movement, so 700 into 3 cos 60 degree. So from here MB is equal to 1000 plus into cos 60 divided by 6 sin 60 . So this comes out to be 298.297 Newton. Now since it is mentioned in the problem that it is the ladder is at the verge of slipping, so I can write friction as mu s into NB, right? Sorry, NA, it should be NA, not NB. Now I also know that friction equals to NB, right? So mu s equals to FA by NA. Now FA is also equals to NB, which we got as 298.297, and NA we found out to be 1200. So this becomes 0.25. So is there a doubt? Is there any doubt regarding this? Okay. So what are the question? What is the coefficient of static friction? So we already calculated the coefficient . 0.25. Next problem. What is the magnitude of frictional force developed in Newton at the stage? So magnitude of frictional forces Fa, which is equal to NB, right? That is equal to 298.297. Next part is magnitude of normal force at point B, which is also the same. Now, next problem. A system with two boxes P and Q having masses 10 kg and W respectively are connected as shown using smooth wheels and a smooth pulley. Answer the following questions considering wheels, pulleys and cables to have negligible mass. So first you need to find the magnitude of the resultant normal force in Newton at box P and floor interface. So first try drawing the free body diagram for this system. Can someone tell me what is the magnitude of normal force? Okay. Okay, so I'll first draw the free body diagram. Now there is a tension in the cable, right? So this is T, this is T, and this is T. So what is the total tension on the acting on this block T? It's 2T. Now let this be the normal force N1. And the weight is acting downwards. So can you tell me what is this angle? This is 10G, right? Yeah, 10 kg. So can you tell me what is this angle in between? This angle should be 15 degree, right? So this angle is 15. So this is also 15 degree, right? Did you understand this? Is there any doubt regarding this? So I'll now just resolve the force along the direction of normal to this block. So I can write this as N1 minus 10G should be cos 15, right? Equals to 0. So N1 equals to 10 into 9.81 into cos 15 degree. So N1 equal to 10 94.76. Now the next part, consider box P to be at the verge of sliding down the inclined plane and answer the following two questions. So since it is mentioned that the box P is sliding down the incline, so can you tell me in which direction is the frictional force acting? It's going down the incline. So what should be the direction of the frictional force? It should be in this direction, right? Since the block is going down the incline. Is there any doubt regarding this? Am I audible? Okay. So is there any doubt regarding this? Since the block is sliding down, so the friction will act in the upward directions, right? Yeah. So now, and it is also mentioned that it is at the verge of sliding. So I can write F1 equals to mu s times n1, right? So F1 would be mu s time n1 and mu s is given to be 0.15. So mu s is 0.15. So F1 is 0.15 into 94.76 Newton. This is equal to 14.21 Newton. Now the next part of the problem. What is the minimum weight of box Q in Newton to keep this configuration equilibrium? Now we drew the free body diagram for block P. Similarly, we need to draw the free body diagram for block Q, right? Now it is said in the question that T is going down the incline. So Q will go up, right? It is mentioned that P is sliding downwards, so Q will automatically slide upwards, right? Is this clear? Yeah. So now we will draw the free body diagram for Q. Here a tension is acting in the upward direction and also the weight of the block is acting. Now this angle should be 12 degree. You can see from this figure Now T will be W cos 12. And from the previous free body diagram, writing the force equilibrium along the inclined plane, we can write this as minus 2t, plus 2t plus F1 and minus 10g sine of 15 degree. Now we already know the value for frictional force, right? We already calculated F1. That is this one. So I'll just substitute. So this will be 5.59. But we need to find the weight. So weight is T by cos 12, right, from this equation. So W is T by cos of 12. So that is 5.59 divided by cos 12 degree. This is 5.71 Newton. Now the next part, consider box Q to be at the verge of sliding down the inclined plane. Now it's just the reverse situation. See, they have asked that, they have mentioned that this box Q is going down the incline. So what change we have to make to the free body diagram? Can you tell me? Earlier Q was moving up the incline since this box P was sliding downwards. Now they have mentioned Q is going down the incline. So what changes do we need to make to the free body diagram? The direction for frictional force will be reversed, right? Earlier the block P was moving down and now it is going up. So the direction for frictional force will just be reversed. So can you just try solving this? You just need to reverse this direction and follow the same process. Draw the free body diagram, reverse the direction for frictional force, and then you will get the weight W. Just try solving this. Did you get the value for W? So this is the free body diagram. Now this block is moving up the incline, so the frictional force will be in this direction. So this is the weight, and this is the normal. So I'll write I'll write the forces along the inclined plane. 2t minus of F1. This angle is also 15 degree. Minus 9.81 into sine of 15 degree. So this is equals to 0. Now 2t equals to F1 plus sine 15 degree. And along the normal direction, I can write this as n1 minus 10 into 9.81 cos 15 degree equals to 0. Now, since it is on the verge of slipping, F1 will be mu s times n1. Mu s is given as 0.15. Now, from this equation, 2t equals to F1 plus 10 into 9.81 sine 15 degree. Therefore, t should be F1 plus divided by 2, which is equal to this is equal to 19.8. Now this block is going down the incline. So, will there be any change in the direction of force? Can you tell me for this block? Will there be any change in direction? No, right? Weight will be acting in this direction only, and tension will act in upward direction only. So again, T will be equal to W cos 12. So from there I can find W. So T equals to W cos 12. So W equals to T by cos 12 degree, 19.8 cos 12. So it is 20.24. Now the next question, what is the magnitude of tension developed in the cable? So this we already found out here. So is there any doubt regarding this problem? You can tell me if you have any doubt. Okay. So this was the first problem that we discussed today. There are two arrangements. So in the first case and the second case, we have drawn the free body diagrams. We have to find out the ratio of the mechanical advantage in both the cases. First we need to find the mechanical advantage in both the cases, and then we need to find the ratio. So PA equals to 10G. So mechanical advantage is 10G by PA, which is 1. And for the second case, case B, 10G equals to 2 PB. From there we get PB is 5G. So the mechanical advantage for this second case is 2, and the ratio between the two systems is half. This is a simple question. The condition of self-locking is influenced by which of the following parameters? In the third problem, here a couple M is applied on the wheel, and first we need to find this angle theta. From there we can solve the problem very easily. So we know that this distance is 75 because we know the radius. From there we got theta equals to 30 degree. Now we draw the free body diagram. In the y direction. So normal force comes out. We can evaluate normal force from this expression. Similarly, along x direction, we get P in terms of mu s and normal force, which we substitute in 1. So after substituting this value for P in 1, we get the normal force, and from the normal force we again get the force P. So in the current configuration, link AB is a two-force member under axial compression. That you can see only from this figure, that this member is under axial compression. So this is true. Now for the second part of the problem, normal force we already calculated. And they are asking the magnitude of force in Newton experienced by link at point B, which is nothing but P. That also we got. Then they asked to determine the applied couple M. So we just calculated moment about the point O, and from there we get the moment M. So is there any doubt in this problem? Okay. So in the next problem, this wall is smooth and the floor is rough. So accordingly we draw the free body diagram. So writing force equilibrium along the x direction, we find out NB equals to Fa, and along y direction we get Na. From there we calculate moment about point A, which gives us NB. Also Fa is mu s times Na, since it is already mentioned in the problem that the ladder is at the verge of sliding. Is at the verge of slipping. So we can write Fa equals to mu s times Na, and also from this equation NB equals Fa equals to NB. So in place of Fa we can write NB. So we get mu s to be 0.25. So they have asked the magnitude of frictional force, which is nothing but again NB. And normal reaction at point B, which is again NB. And this is the problem we solved just now. So is there any doubt regarding this problem? You can ask me if you have any doubt regarding this problem. Okay. So if there are no doubts, we can stop here then. Okay. So for this week, these are the questions that I prepared. So we can solve more problems in the next week, okay? Okay. So we will stop here then.